Hi everyone. My name is Victoria and I'm going to be your moderator for the next couple of hours. Please let me know in the comments if you can see and hear me well. I'm really glad and excited to be here on the second day of the Worldwide Software Architecture Summit. I also would like to welcome our attendees who just joined us from the CST time zone, for who this will be the first block. I'm sure you're gonna enjoy it and get ready for absorption of all of this valuable and definitely interesting information. So, before I start presenting our first speaker of this block, which will be dedicated to serverless, I would like to remind you that you should definitely take a chance to win a ticket for an upcoming Geekle event at your choice. Write your question to our speakers in the comments. Use question for ticket hashtag. I'll share it in the comments as well. And in the end of the summit, we'll randomly choose 5 lucky winners to provide with a ticket. Be active and let the luck be on your side. So now we are ready to present our next speaker, who will be Runcy Oommen, who is a SonicWall principal software engineer with strong CDLC experience and a string of projects primarily in the security domain. Runcy strives constantly to build better software with extra focus on data security that would be kept throughout its lifestyle and not just as an afterthought. Considers himself to be a perfectionist, yet remains practical, knowing where to draw the line and stop. His hiring focus on cloud revolves around serverless containerization, microservices, cloud native, and multi-cloud workloads. He is going to present us his talk, Serverless Solution Architectures in AWS. As Rancy was not able to join us as for live at this session, we are going to show you the recording of his talk. But please do ask your question as he will join us after on the group Q&A session. So be ready for this talk.
Hello, everyone, and welcome to the World Software Architecture Summit. My name is Runcy, and I'm super excited to be presenting in front of you about the serverless solution architecture focused around the AWS architecture, right? So let's get started. And this is sort of like my promise for the next 30 to 40 minutes that we have. And I'm going to get the ball rolling by introducing you to what serverless is, how it evolved, and what are the advantages as compared to the other models of cloud execution, right? And I'm going to give you like a brief overview of what the serverless in the AWS ecosystem is, and what better is to just show you by a real example, right? And I have sort of like a really cool application that I've built for this demo. And I'm going to give you like a rundown of the various AWS services that we are going to be using, whether from the databases, the identity access, the Lambda functions that's going to be there, the integration with the API gateway, how you actually going to host your websites or your static content on S3, and how it can be distributed across by using the CDN services and sort of like the distribution surface with the Route 53 or sort of like the DNS redirection, right? And then the second phase of this presentation is going to be talking about the full stack serverless. So the first one is basically giving you like a rundown of the various in-depth steps that needs to be done. And the second phase is basically getting it you introduced to AWS Amplify that helps you get started with the serverless solution at sort of like a different level, right? So before that, I want to give like a brief introduction about myself. So I'm a principal software engineer at Sonicwall, a few years of experience under my belt, but primarily in the cloud security and the networking domain. I am multi-cloud certified in across all the providers. Also hold a patent in cloud security around the distributed data storage. And I am a firm believer of the multi-cloud and particular interest around serverless containers and the cloud native offerings. On the community side, I lead the GDG Cloud, the AWS user group, and the cloud native community in Bangalore, speak at regular conferences. And I also have won multiple hackathons in the cloud security topics, right? And also being recognized by Google as sort of like a community influencer. So, uh, with that, I want to set the context and I want to do it by sort of like taking this definition from the Wikipedia, and all of you can read. And I'm not going to repeat this, but just look at the ones that's been underlined, right? It's sort of like the serverless, it's nothing special. It's just a cloud execution model, but it's different. But how it's different? Because the cloud provider is going to run the server for you. You are not in charge of what is going to be run, right? And because it's being run by the provider and managed dynamically. So that's the whole difference that you have to understand as to what the serverless means, right? And we are going to get deeper as to what it actually means, right? So again, just to drive to the point, it's basically about building and running your applications at scale or even probably at a low scale level without actually thinking about the service. So you think only about the code and your application and you think nothing about the capacity. And when I say the capacity, it's basically about the storage, networking, and the compute. So you don't think about those sort of capacities, right? So it basically removes, or the serverless is basically removing the need for provisioning and utilization. Yes, operations are a zero management, sort of like the no ops way of actually doing it. You scale automatically, whether horizontally or vertically, and it's available across with a high amount of fault tolerance. And because it is being provided with the abstraction of the servers, because it's completely hidden, you are basically not dealing with it in the that layer, and because it's event driven, so it is basically provisioning dynamically when there is sort of like an event that's been kicking and you only pay for what you actually use. So that's sort of like the advantage that's being provided with the serverless offerings, right? So how did we actually evolve here? Because this did not happen overnight, right? And on the bottom left, you actually see the bare metal offerings that's been started, right? It's still there. You acquire the hardware and you mount it on the rack, and then that's how it all began, right? The server definitions. That's pretty much it. It's part of the data centers that's been there, right? And then the next evolution sort of happened with the VMware bursting into the scene. And then the VMs just became the de facto standard for all of it, right? For getting your stuff done. It still is some of the most popular way of getting things. And that's evolved into the container model, right? When Solomon Hykes announced Docker in 2013, I guess, the whole containers came to the scene. And Google has been doing it at much larger scale before that, but sort of been democratized with the whole Docker perspective. And that's how the container things. And the next gradual evolution was the Lambdas that got introduced in AWS re:Invent in 2014. And that's sort of like the fast definitions of doing things, where you only think about the code in how it is being run. And that's sort of like the evolution where we're getting there. So, right, from bare metal to VMs to CAS, or the containers as a service to FAS, the functions as a service, right? So when you actually think about serverless, this is sort of like the analogy that I want to give, right? You don't actually think about the serverless just as fast. Fast, as you can see, it's sort of like a piece of the pizza, right? Serverless is a whole encompassing things of other things. Like, for example, S3 is serverless, the way you actually serve, right? BigQuery from Google Cloud, that is serverless, right? Because you are not provisioning or running any of your stuff. But FAS or the Lambda or the Google Cloud function or the Azure functions, those are not the only serverless offerings. Those are just the FAS offerings or small subset of the whole serverless services that exist out there, right? So with that context that's being said, I want to just introduce you to what we actually are building, and I want to give like I want to do it something fun. And what better way than to explain about all the t-shirts that I have, the various technology t-shirts that I've been collecting from the various conferences, right? So we are going to build a fun application that's going to describe about the various t-shirts of Runcy, right? And give you like a brief introduction about what those t-shirts are and when they're acquired, right? So let's get started, right? So enough talking. I know all of you are here to see the stuff. You've paid for this conference, so let's just get started and let's get the ball rolling, right? And here's sort of like the prerequisites that we actually need to begin. We need the AWS suite here, obviously, And all of these things that I'm going to talk about is not going to cost you a single dime. It's all going to be within the AWS Studio, right? You can get the source code from the GitHub. So I've given you the link for it. Feel free to fork or download or whatever, and then you can just get the whole source code to play around with it. And just a very bare minimum understanding of Python, most English-like language, HTML, JavaScript, and CSS. It's not a whole understanding, but just a required amount, right? And a good IDE like a Visual Studio Code, which is again free. And this is, I am under the assumption that you already have a domain, or if you do not have, just purchase a domain and you can have it hosted over there. So I already have a domain, and we are going to host it as a subdomain for this particular application, right? So the first step is obviously setting up the database, and we are going to be using DynamoDB, which again is a serverless offering from AWS. So right, so just select the data from the DynamoDB from the database section, create the table, and it helps you get started. So what I've done over this next few slides is, instead of giving you like a demo which would go all haywire and if the demo codes are not working, I've taken up the relevant screenshots and I've put it in the slide so that when you get the slides, which obviously would be sharing to the organizers, you can actually go back and then look at this screenshots and then get you hands on with it, right? Rather than just watching the video again and again, right? So just select the create table to help you get started with that. And then just provide a simple table name, a primary key. So it's sort of like a partition key. That's what we actually call in DynamoDB. So in this case, it can be like a unique identifier. We are giving you the ID for various things, right? And then just use the default settings, leave the rest as default, and then just click next, right? And you have to start adding the items by clicking on the create items, right? So what you have actually done is I'm going to add my various items, which are going to be my t-shirts, right? So it's a very simple DB schema that is nothing but the ID and the description. So I add the ID number one, and I'm going to give a description about one of my t-shirts that's just there, right? So with that, you keep adding it, keep adding whatever you want. I've done a bunch of additions for all of my t-shirts, and there you should be having a relevant database, right? Now, the next part is about the IAM. So you select the IAM from the security, identity, and compliance services in the AWS. You create a new role by clicking on it, and you select the Lambda as a service. So you're going to be using the Lambda, which, because it's serverless, so you want to have the Lambda as a services which is going to be using this role. And then just click next to attach the permissions to it, right? So what are the relevant permissions that we actually want? So just select, you want the Amazon DynamoDB full access, you want the Lambda to be executed, so you just give the basic execution role for it, and then select the Lambda VPC access. So VPC is sort of like a construct within AWS that helps you set sort of like the networking perimeter within your area. So it's sort of like your own data center. Yeah, that's the analogy. Your own data center within the AWS. So that helps you give your execution within that VPC, right? And you add the appropriate tags. So this is optional, but highly recommended because it helps you from a building perspective, right? So you can add the appropriate tags for it. And you can give an appropriate name and you can just create the role. So I'm giving you the role as teas.runcy.me, which you can guess right now is going to be my website on which this is already hosted. And you attach the policies. So this is sort of like the review that's going to be there, right? So with that, the IAM is now set. And now the third one is basically going to be making some facts, right? Going to make some facts, right? Fun way of doing it. Now you select the Lambda from the services list under the compute, and you provide the name, runtime, and you have to choose the role, right? So you give a function name, appropriate function name. You choose the runtime. So we're going to be writing all of our code in Python 3. So you select the runtime environment and you create an use an existing role, right? So instead of you've created the existing role in the previous steps, you just select that from the list and it will just automatically get listed over there, right? So in this web example, so we have this short T description. So that's sort of like our only function that's going to be doing this thing, right? So we have this t-shirt that is there, and it's going to show you the t-shirts when you do a mouse over or click on top of it, right? So we've added those t-shirts in DynamoDB. It's going to now show you the description when for this one, right? So for Python, when you actually have to do it, to be integrated, you have to zip all the source code and dependencies if any. So now here we do not have any dependencies. Well, we use Boto 3 for basically fetching it, but Boto is actually a dependency within the Lambda runtime. So you have your Python, this thing, you right click on it and you just say send it to a compressed file. So your Python code is there, just make it a zip file, right? And as I said, Boto is the dependency that we have, but guess what? It's already part of the runtime. So you don't have to explicitly do or download those dependencies. And then, but if you're using some other packages within Python, just make sure that it is extracted it out. And then that is within the zip file that you actually got. So you can read about more about it in the AWS documentation for Lambda for with Python. I don't want to get deep dive into it because that's sort of like a different discussion altogether, right? So now you should have the zip file which is ready to be deployed. So just verify the contents by clicking on it, and then you should have it exactly like the screenshot. That is, the Python file should definitely be available under that same hierarchy on when you open it, right? So go to the Lambda section again, and then you have to upload the zip file. So you select the zip file from there, you choose the runtime, and you have something called as a handler. Now, the handler is very important, right? The format of the handler is very important in AWS Lambda. For Python, it should be Python file name dot lambda underscore handler. So we have the Python file name as show t description, I believe. Yeah, show t this, and so that name should be showtthis.lambda underscore handler. So that is the way in which the AWS Lambda is going to know that this is the file that I have to extract and then execute it. So that's sort of like the name to ID mapping. It's sort of a thing that the Lambda does internally, right? So that it gets executed. So you have to provide the appropriate description if you want to, and then just keep the memory footprint. So this is where you actually specify the saying that if you have sort of like a really large file that you want to execute and you feel that this is going to be needing more time, more capacity in terms of memory, feel free to use that slider all the way to the right, and then you will get the memory allocations if needed. But ours is sort of like a very small thing, and 128 MB of the default execution memory footprint would actually, and I'm pretty confident that it will not exceed a whole lot of time. So I'm going to keep the default timeout as well for I think 3 seconds or maybe even like 5 seconds should be okay. You just click on save and you have the Lambda functions that's been created. And once it's created, it will get listed over there as the Lambda functions that's been there, right? So your Lambda is now ready to go. But it's just sitting there. You need to have it invoked, right? And you have to invoke it by something called as an API gateway. And that is the one which is going to be invoking your Lambda because you can create any number of Lambdas you want. But it's just going to sit there. It's not going to cost you anything, but it won't do any work. And now this is where you have to integrate it. So you choose API gateway from the networking and content delivery. You create the API. You see where this is going? So now we are going to be creating an API that's going to be invoking the Lambda, right? So you choose the protocol. So here we are going to be using the REST protocol. You are choosing a new API. You are giving the API a name, and you're choosing the description of the endpoint. So here I'm going to choose a regional endpoint, right? And now you're going to be creating the resource, right? So you choose the resource and then you make sure that you have the API gateway CORS enabled. So CORS is, or the cross origin request, sort of like something that helps you execute a domain if it is like in a different domain. Obviously, we need the CORS to be enabled because the Lambda is going to be executed in a different one and the API gateway is going to be there. So you want the ability for your API to be called as a separate one. So you just make sure that it is there. You provide the resource name and then enable the API gateway course, right? Click on create resource. So now you should be able to have the resource created. So by default, it will just create the options request, right? So that's the default, but that doesn't do anything. It's just a mock request that's just there, right? For now, you need to have to create an other method or a post method. So you click on create method, you choose post from the drop down, and then you have to now create this post method, which is now going to be invoking your Lambda function. See, so when you do that, you choose the integration type as the Lambda function, you choose the Lambda region. So I am in India, so I choose the Mumbai region, and you choose the Lambda function that's going to be which we created earlier, right? So now you choose the region, and we have created the earlier integration that is now complete. So with that, we now have another method that is being distributed. So you have the post method that is also getting showed up. And you click that method and you are going to enable the course for that particular method as well, right? So just be on the safe side, right? So leave everything is it, and you would see this pop-up that is just going to come up. You enable the course and just replace the existing course address. Nothing much. So it's just going to make sure that it is there. So now your API is basically ready, but you have to now deploy this. So you can go to the action and you choose an option called deploying the API, right? And once it's deployed, this pop-up is going to come. You choose a new stage name. You give the stage name a name, description, and the deployment description. So this is sort of like the first version of the Runcy piece, right? So, and then you click on deploy. So now you will see something like this. You will have the invocation URL, which will now be provided by the API gateway, which when clicked is going to trigger the AWS Lambda function, which will invoke that Python code to do all that task, right? So you see where all this is ending up right now? That's the whole integration that's just coming in. And you have to now have this invoked from the API, right? So you have this JavaScript function, which is there in that GitHub repository that I've given you, right? So now you have to use an Ajax call to basically invoke this. So you take that endpoint, you paste it in that URL that's been provided over there, and that's how you have integrated the API, which will now be invoked from the JavaScript function, right? And this is the serverless trinity that's just been coming together everything. So you have the HTML file, which has the JavaScript function. The JavaScript function has the URL, which we have now created from the API gateway. And that API gateway is going to call the Lambda function, which is being now created in the Python file. So you have the HTML code, the JavaScript code, and the Python code, which is now all going to work in a very, very well, good harmony, and just this serverless way, right? So that's how the whole integration is going to play out right now, right? And how it's going to be playing out is after you host your files on the S3 bucket, because hey, we have this JavaScript file, we have this HTML file, but we don't have a website yet. Yes, we have the Lambda function, which is now going to be invoked by the API gateway, but we want to see the real thing, right? We want to host this website. And this is how we're going to be hosting the website. So you choose the S3 from the services list, you click on create a bucket, and you provide the appropriate bucket name and the region. So you choose the region where you're based out of, you provide a good bucket. So runcyspeeds.com, right? Whatever the bucket name that you want, and you click on create, right? So from that, you select the bucket that you created earlier. So the bucket is ready, the keys.runcys.me, right? And you give the static website hosting. So you go to the properties tab and you choose static website hosting, right? So from that, you will automatically be given an endpoint. So now if you click on this endpoint, your website will be ready to go, right? But that's not a very large endpoint. So you have this endpoint that is being automatically being provided by the S3 when you enable this. And you give the index document. So in our case, it is index.html, which is going to be hosting this. And whenever you hit this website, it's going to redirect to index.html. It could be anything, home.html, whatever your website repository is. But in the repository example that I give is index.html, right? That's the starting point. And then you go to the permissions tab and you have to give this bucket policy. And what this bucket policy does, it's going to make your bucket a world readable because, hey, it's a website which should be accessible to everyone, right? So that it should be readable. So this policy, you can get it from the link that I've given in the footnotes. Just pick it up and then just replace the thing that is there with the bucket ARN name with teas.runcy.me, the what bucket name /star. So it's going to give you access to all the contents inside that bucket with a policy of allow, and it's going to do an action of get object. So every time you hit this, it's going to get that object, everything under that bucket, which that's forward slash star, which is the wildcat character, right? So with that, the bucket is now public. Now we need to create a certificate. How good is a website if it isn't secure, right? So we need to have like a SSL certificate. Yes, we are gonna be making a HTTPS enabled website, not HTTP one. And that is also being provided by serverless with the certificate manager. So you choose that service from the AWS, choose the region as North Virginia, and this is very important because the North Virginia region is the one which will provide a certificate that can be integrated into a CDN network that will come into the later, the CDN or the cloud distribution network or the cloud front in how the AWS parlance is where it basically helps you distribute your content across the globe. But more on that later, right? So, but you make sure you choose the region as North Virginia. You click on create or request a certificate and you request a public certificate, right? So that's the default option that's there. You give the domain name. So now I already have a domain called runcy.me. I'm going to host this as a subdomain, the teas.runcy.me. You choose that and you click next. You have to do a DNS validation. So depending on how you want to do it, my domain runcy.me is already hosted in the Route 53. So I'm going to do a DNS validation because I just want to create an entry in the DNS and to help me the subdomain validator, right? So when you enable that, this option default comes and you just have to click on that to create the record. And the entry would be created with the CNAME entry that would be there. So it could be in any of your, it may not be Route 53, right? Because your domain could be hosted anywhere else. So just copy the CNAME entry and just paste it on your domain provider, right? And with that, the certificate would basically be issued. Usually it takes about 15 minutes after the CNAME entry is being created. That's what I observed with Route 53. So now the next step is to make your website accessible across the world. Because remember, my website is in the Mumbai region, but I would have users from Australia or Europe or North America, right? And I want that to be served very fast rather than making like a halfway trip around the world, right? So you choose something called a CDN, and the AWS provides something called a CloudFront, which is sort of like a managed CDN for that particular, or the content delivery network, right? So you create a distribution. You choose the web as sort of like the delivery mechanism that you want to actually do it, and you choose the domain name. So obviously, my domain name is the S3 bucket, so I'm going to choose that, and automatically gets populated over there, the domain name that's been provided, right? And you choose the protocol. So I want to redirect everyone who's going to come into this CloudFront distribution to basically redirect all the HTTP traffic to HTTPS, right? And how you're going to do that is by using that certificate that they actually created. So the CloudFront is going to be creating a default name, but I want to redirect that to a C name called teas.runcs.me because CloudFront is going to be creating its own subdomain. But hey, I want my domain to be like a good user spelled domain, right? So teas.runc.me, that's my $1 million website. So I give that C name and I give that custom SSL certificate, so which we created earlier. So teas.runc.me, when someone hits, it's going to hit to the CloudFront distribution, it's going to translate that, it's going to pick up the certificate, and it's going to look into the S3 bucket, right? So that's how the redirection is going to be there. We choose the default root object. So again, just like when we created the distribution earlier, so again here, the S3 bucket earlier, again here, again, we have to give the default root object. And it's the same thing depending on your website. In my case, it is index.html. You create the distribution and wait for the distribution. It actually takes about 30 minutes for this whole distribution to basically go through this whole process, right? So with that, we want to just do the DNS redirection, and we use something called a Route 53 to basically do this. And you choose the hosted zone that you want. So here I have a domain called runcy.me that is hosted already on Route 53. And that's the reason why you choose that. So you have to create a hosted zone for your particular domain. Click on create the record set. And here I'm going to create the record set called teas.runcs.me in the record type as CNAME and the value that I received with the default CloudFront domain, right? So whenever you hit teas.runcs.me, it's a CNAME domain that's going to be redirecting it to this CloudFront location, which again is going to talk to the S3 bucket. So we have created this whole redirection process that's going to serve this super cool website, right? So with that, the website should now be live, and we should all be now be able to access the keys.runcies.me super secure website. I'm just kidding. The $1 million idea will entirely with the AWS serverless components. We have not used a single EC2 instance or any bare metal instance. Like all of the components that's been just mentioned in this icons have been used, whether it be S3 bucket for hosting, the AWS Lambda that is going to be running the fast computations, the IAM that's going to be dictating the services of the roles, the certificate manager that we use for issuing the certificate, the Route 53, the DynamoDB that's going to be our website. So all of this is now working in harmony to basically serve this for you, right? So with that, I want to shift gears a little bit and then talk about the second phase of this presentation that is about the AWS Amplify. Now, the whole point why I've kept this later is because everyone loves to have a good hot dog, right? But sometimes you also have to learn how to make a good sausage, right? So the first phase was basically about learning to make the sausage, and the second one is about bringing it all together to make a good hot dog, right? So AWS Amplify is the hot dog, right? And what it actually provides is basically it helps you give a JavaScript library and a tool chain to help you build mobile and web apps, all powered by the cloud, right? And it helps you deploy these things fast. Now, the last 30 slides, we've been talking about multiple steps that's been needed to build a very simple static website. But with AWS Amplify, with few commands, you'll be able to do that. And I wanted to give you this power, but I wanted to give you this power after the background that we had said earlier, right? So as I said, AWS Amplify gives you that CLI support that's been there with helps with integration, the A&A, the authentication and authorization support, and helps you integrate with the REST and the GraphQL APIs. And the tool chain, right? With various simple commands that's been provided by the tool chain, AWS uses CloudFormation in the backend to help you enable, modify, and share the configurations for your web and mobile applications, right? So the CLI and the tool chains are being provided by the Amplify. And it helps you host the static website. So it helps you distribute the content to the end users with very low latency and with the high data transfer speed. And it also provides a secure, simple, and storage infrastructure, right? The S3 we've talked about earlier, the distributing contents of the CDN and the CloudFront and the API gateway, and performs something better as compared to what we described earlier. It helps you give a local testing of AWS Lambda. Now, we talked about the AWS Lambda development earlier, but this AWS Amplify, it helps you give some sort of like a unit testing if you're dealing with Lambda at scale, that is with multiple functions. And this is where the true power of AWS Amplify comes in the picture. And it helps you deploy, create APIs. So we talked about the API integrations with the API gateway, right? With AWS Amplify, it is even possible, and it helps you integrate with GraphQL and also REST. But with API Gateway, it was more of a REST integration. Here, it gives you support for GraphQL integrations as well. And the tool chain basically helps you integrate with implements all of your CloudFormation template that implements your data model. So that's sort of like the true power that comes with it. And it's integrated with very well SPF frameworks, so the single page application frameworks, so whether it be Vue, Angular, Ionic, React, React Native, all the major providers are being helped integrated with yours. And it helps you support this integration with the various AWS services. And what are those services? Well, it helps you integration for the authentication in terms of Cognito, right? We had to use IAM in our case. The storage, yes, there is this definition for support for SP and DynamoDB. We saw that earlier with our example in phase one. Functions, we use AWS Lambda. Yes, that integration is being provided with AWS Amplify as well. The API integration, we saw that. You can have it with both, right? The hosting, we saw the S3 bucket hosting. The analytics, so this is something extra that the AWS Amplify provides. It helps you integrate with the pinpoint and the interactions if you want to do sort of like a NLP application with the Amazon Lex, right? So it is now safe to say that the serverless is definitely eating the stack because we have built a classic three-tier application, including the backend, the middle layer, and the front end, using all of the services which are serverless, and whether it be in phase one or phase two. I want to touch upon phase two, but more from like a 10,000 feet overview. I don't want to deep dive it, but the phase one, we explored in deep dive all of the services, whether it be in the backend databases, the middle tier, or the front end, to helps you do this. And it is basically done the full stack applications without managing a single node of CPU, right? So that's the power that the serverless harnesses, right? So with that, I want to conclude and I want to thank you everyone for listening once again. And it's been a great honor to present to all of you. Do try if there is anything particular that you are interested, do reach out to me. This is my handle to basically reach the my website and my Twitter handle. Feel free to check it out, and then we can hopefully connect and then just take the next learning. Right? So thank you again. Thank you all for having me, and pleasure talking to you again.
Okay, thank you, Ramsey. And now we are already ready to meet our next speaker, who is Jess Martin. Hi, how are you doing today?
Doing good. How are you?
I'm doing great. Very excited about your and all of our next talks. So, what I can say from there, Jess's like bio, the one that we have, that we know that he has helped companies of all sizes embrace serverless architectures through the power of GraphQL, proper schema design, and event-driven paradigms. So I assume you are going to share some valuable tips and experience with all of our attendees, right?
I will do my best.
Oh, I'm sure you do great. So everyone, don't forget to ask your question below, as Jess will be able to answer them on our Q&A session after. So Jess, you can share your screen.
Very good. I actually will drive it from here. So I'm going to speak for a minute and then I'll switch to my slides. I'll be using a camera setup to do my
Okay,
thing.
then please, the stage is yours. You can start now.
Thanks. So, as they announced, I'm Jesse Martin, and I am now actually, as a bit of a yeah, coming clean. I'm no longer solutions architect. I was for a while. Did a lot of digital strategy for some banks, things of that nature. Now I am product marketing for a company called Hasura. But the time when I agreed to this talk was back when I was still doing solutions architecture. And I actually think that I have some helpful tips to kind of share. So I was told that this track is the career track, and I'm coming from the angle that there's going to be a lot of you that are potentially wanting to deepen your skills in solutions architecture to understand where to get started. And I'm going to try to give you a combination of some powerful tools plus a little bit of a soft skills pep talk to help you figure out kind of your path forward in this space. And I think should be helpful. So I'm going to go ahead and share some slides here. And my talk here is going to be called Faster Serverless Prototypes with NextJS and Hasura Cloud. And we're going to go ahead and cover some of those pieces in a minute. But basically, let's start off. So who am I? Again, Jesse Martin. I'm product marketing for a company called Hasura. I do a lot of developer kind of engagement and talking on Motley Dev. Twitter. So if you want to like kind of follow me and see sort of some of the things I dump, I've done solutions architecture, I've done developer relations. I tend to just spit that content out. And that's sort of my primary dumping ground. So feel free to find me there and I will be happy to engage with you on any topic. And so I kind of come into the presentation that I have for you today. I want to talk about I would like to kind of start off with what we are learning or looking at the actual primary pieces. And so in this space, we're going to talk about defining our terms with my talk title. We're going to talk about defining our tools, and then we're going to talk about actually defining our solutions. And I'm going to show you real life prototype in the process, what I'm working on even right now at Hasura. Let's start off with defining our terms. And to do that, we need to start off with the idea of what is serverless. Now, most of us are familiar with the concept of serverless, but there's a couple of key pieces that I think are really critical for us to sort of bear in mind about the topic of serverless. So serverless itself, at the end of the day, we're essentially calling host functions. So the serverless architecture says that there is some sort of a runtime that is executing a specific function at the given request time for what I wanted to do. And in that, it's basically allowing me to save on a lot of costs. I don't have to run a huge architecture. It's allowing me to have a lot of flexibility in the providers that I use. And so when we talk about the second point about serverless, this plug and play, basically mix and match these different services that are important for what I'm trying to accomplish. So if I say that I want to have an authorization service or something, I can choose from any number of providers and sort of put them into the architecture that I've designed. And when we're talking about the prototyping phase, that's really important for us to be able to say, I'm going to scale up, or I'm going to start with something that's maybe a little bit faster to get started with, or something that I'm comfortable with. And as that prototype becomes accepted by the clients and the stakeholders, it could be you need to swap it out for an enterprise grade single sign-on solution or something. But the typing phase relies heavily on this idea that you're allowed to basically kind of mix and match these encapsulated services for what it is you want to accomplish. And in that, and it's very important for prototype people, because a lot of times the prototype is the pitch, and we're actually in a phase where you're trying to get sign off on the project you're trying to get the person to buy. And these service architectures, or the fact that you can just scale these individual function calls, means that the rise of the free tier is really a thing. And you can say that for the prototype phase, I may have 500 requests on this function in total. And you'll fit very comfortably in a lot of these cloud providers' free tiers. And then you're allowed to actually scale that up when it starts to scale to the hundreds of millions, depending on the project that you're actually trying to execute. So these are some three quick points about the term of serverless as I use it. And I want to say that there's a really fundamental doctrine behind serverless that basically just states that if somebody else already built it, you can't build it better and cheaper. You could probably always build it because code is progressing so quickly, but you can't do better and cheaper. And so one of the primary tenets of serverless architecture is to say, if somebody else built it, then you should use what they built. So it doesn't really matter what the service is, authentication, whether it be managing your API layer or Stripe or whatever else you may want to from a particular stack. If it exists, use what somebody else created, because again, we're talking about the prototype, talking about getting speed here. And in the service world, if somebody else did, it's done. You don't need to reinvent the wheel. So next up, we have serverless architecture, and this is going to come into play in a little bit when I kind of show the idea of the architecture I'm going to present to you, and in particular with the tooling that I want to propose as powerful tools for a solutions architect today. And that is that serverless is really a lot about an event-driven architecture. And so when you talk about invoking functions that are hosted on different stacks or in different services all around the globe, what we're really talking about is this event or this service needs to have some way to now invoke that service somewhere else. And so I can say on a successful authentication, now I'm going to go ahead and trigger an event on some other service with potentially some extra data, such as a JWT token or something of that nature. But we're talking about a really important concept here in serverless thinking to say that we're really talking about composing order which events occur and which events will talk to the other event. So in this kind of little diagram there, you have the action taking place from the app, which triggers something in service, which triggers something in service 2, which then actually pushes the data back to the interface. And so the service you're calling may never actually be the one that is responding back to your interface in any kind of a meaningful way. So important concept. If you have questions, fire off there. I'm happy to touch more on that in the Q&A later on. All right, so prototyping now. Prototyping is a very important skill for a solutions architect to learn, because what we're talking about is that getting through to the believable adoption, believable acceptance of the product we're trying to sell, or the concept we're trying to demonstrate, or the pitch we're trying to win. And so it's a really powerful skill that allows us to that just believable enough phase, getting the sign off or getting the iteration or getting the feedback from the client, go back, be able to have tools that are flexible enough and fluid enough that are going to allow us to iterate on this prototype and push it back out. But in that iteration phase, it's important, though, that our prototyping is able to essentially, or relies on 3 heavy primitives here. One is that the prototype itself needs to be able to scale to production. And so with that scaling to production, what I mean with that is that the tool, and this is usually, again, relying a lot on the serverless underpin of what you've used to architect this out, but the tool you've chosen really should only need a credit card to be able to scale up to a production grade service after a few more rounds of tightening up any hacky code that you may have put in there. And so the idea is that what you've architected here is actually good enough to be taken by a DevOps team. It's good enough to be implemented by a larger production team, or even just yourself, to be able to, properly close all the doors and windows, tighten everything down, and be able to scale that to production. So it's a very important that the tools used are production grade. However, they also need to support fast iteration, which means that the tooling that you're going to be using needs to actually allow you to iterate quickly on changes, that you don't ever hold a prototype too precious, that you can gut out pieces or swap new pieces in without ever finding yourself stuck with the belief that this is the end-all function for, this is the end-all prototype or concept, and that if you had to rewire this, pop in a new state management or something else, that this would cost you another months of work. It needs to be something that you can iterate on quickly, and that's a really important concept. And to accomplish that, what you essentially need is extremely expressive tools, something that allows you to be able to move quickly, allows you to be able to make changes fast, but then again can scale all the way up to what you need. And ideally, you don't have to touch too many tools to be able to accomplish what you want to do. So if I were to kind of carry on with sort of the tenet of prototyping, is that it really is all about moving fast and breaking things that you intended to break. So I am not a fan of moving fast and breaking things that you actually are trying to push into production as like a sign of quality. I'm a big fan of moving fast and breaking things that you intended to be broken. And then ideally you sharpen it up and you iterate over it and you get it out the door. And if you're familiar with the design thinking concepts, they go hand in hand with the prototyping ethos, which essentially you start off empathizing with the customer and you get the idea in place. That moves to the ideation phase, where you're able to sort of say, okay, here's some solutions to solve this problem that the customer has presented. You move to a prototype phase, which oftentimes will kick you back into the ideation phase, and you have a lot of cycles in there. And then you kick it off into testing, which allows you to either empathize with the customer because you're now exposing something new that you didn't realize. Maybe the problem actually was different than you intended. And as a solutions architect, this ability to empathize with the actual problem, not the problem as stated by the customer, but the problem that is being presented in the subtext, that is a really important skill for a solutions architect, to be able to see what the real problem behind it is. And then that testing phase also can lead you right back into ideation as well, where you kick back a few more rounds of prototyping and so on and so on. So I'm really kind of rushing here a little bit. I'm trying to cover some soft elements here as well. I will go into a quick talk about then the tools that I sort of want to pitch to you as to the tools that I've sort of settled into as being the ones that I'm really comfortable with. And I really think that they afford massive performance boosts for the modern solutions architect that's thinking in a serverless prototype first kind of way. The first one is a framework that's called NextJS. Now, this is going to be a little bit specific. If you're a JavaScript dev, if you are talking about prepping, you need to learn JavaScript. There's just not a faster execution engine out there and a way to get paint on the page as quickly as JavaScript can. So I'm going to give a little bit of a dogmatic pitch there. It's time to learn if you haven't learned it yet. But with JavaScript, this framework, NextJS, gives you a lot of what the other languages kind of have that JavaScript doesn't. So it gives you a lot of opinion. It gives you a lot of built-in best practices. And so there's two halves to how NextJS operates and executes. And so the first half is you have the web, esque layers. So you can do both server-side rendered or server-side generated. That's a static site if you're not familiar with that term. You have helpful lifecycle hooks. So you can say, this code should execute in a server. This code should execute on the client. This code should execute as soon as I know that I have a window object available. A lot of very helpful primitives there. Some of them borrowed from the React ecosystem, which is kind of underlying it. You have built-in routing. So basically one file, one route, and also dynamic catches. So you can say, everything after this route, basically pass this in as a catch-all. I'll show that in the real prototype here in a minute. And then you have things like single page application helpers. So passing in routing information, passing in path data, and things that are really difficult to do on your own or are annoying to write from scratch every single time you want to write a modern single page application feeling project. And then for me personally, I actually really like the opinionated framework because it just helps me have a sensible guide rail to say, this is how you should build it, or this is the way that we've proposed it. And I think that the escape hatches that they afford as well to say, I just need to bust out into JavaScript land, or I just need to bust out into React land. Patches are critical for a good prototyping tool because they allow you to say, this is just on the edge enough that I need to kind of pop out into something else. And that's a really important tool concept that's shared by both the framework and the data layer that I'll be pitching on the next slide. And then you have the server side NextJS, which actually says that if you host this on any platform, whether it be an AWS stack, whether it be NextJS's parent company Versal, whether it be any provider, you can actually just essentially drop this folder in place and it's essentially going to run. And you have server-side routing, so you can actually handle complete protected execution. You have built-in body parsing. You have sort of Lambda-esque API routes. Have smooth deployments, and then you have a really smooth environment management flow. So for prototyping, having all of those pieces already solved and having a production grade environment. I mean, Netflix was built on NextJS, or at least it was a while back. Having a production grade tool that allows you to work so quickly inside of it is just super critical. So that's kind of the painting layer. That's the part that you'll be presenting to a customer. Moving on from NextJS to the other half of the tool that I kind of want to pitch to you, which is also, theme for my cover here. Hasura Cloud is by far the easiest way to go from concept to functional GraphQL API in a couple of clicks. And so what Hasura does, which, I put the cloud in there because we have the hosted, which allows you to do sort of the enterprise scale hosting for you. But Hasura itself is an open source project that allows you to go in. You can bring your own data, your own Postgres databases. You can design your own database from raw SQL all the way up to using their pretty elegant UI to be able to say, okay, here's the actual data model that I need to work with. And then you get all of the power of GraphQL. So this isn't a GraphQL talk. I have given lots of those. You can Google my name and GraphQL on YouTube. You'll find something. But if you want to be able to sort of have that move fast, multiple front ends sort of phase of pitching ideas to a customer, then being able to go from data to then a generated API, building in your own event emit system, so you can have built-in actions inside of Hasura. So you could say this method actually needs to trigger an event, all the way through to orchestration, where you can want to stitch this schema to that schema. And it's really a matter of dropping in the URL for the external API you're wanting to use. And now you have a federated schema across multiple services. So extremely powerful and extremely elegant concept to work with. When it comes to defining our tools, you want to think basically that the tools that you choose need to support this offline to cloud process. So NextJS, very elegant offline development environment. Hasura, the same thing. They have migration CLI that allows you to push your code, your schema changes, your seed files, allows you to push that to a cloud and execution environment. So you can start with a really elegant offline first development environment. You want to have something be essentially as self-contained as possible. So again, between those two tools, you can basically solve for 80% of those cases you're going to be given as a solutions architect. And then you're able to just step out for the one or two edge cases, like grabbing an SMS layer from Twilio or something else, depending on the customer you're dealing with. So it's really powerful tooling. I'm going to kind of show a little bit how sort of together. But I want to end with, I want to kind of end with one slide for the tooling section. And basically, the concept I'm trying to teach you here is fear the pen. So we're in the era now of iPads and stylus and most expressive creative tooling we've ever had, Wacom tablets and everything else. And I'm a digital person, and I'll tell you, you still are not going to beat me with a pen and paper when it comes to getting an idea down. And so if you really think about the tooling that we have for expressing ideas, you need to find the most pared down solution that allows you to move quickly to get the concept out the door that you need to get out the door. Yes, if you want to go straight to vector and things, then iPads have their place and everything else. But if you're talking about getting an idea on paper to prove a concept, fear the pen. So really respect simple tools and what it is that they can offer. And that's kind of what I wanted to say in terms of this tooling section. So I'm kind of running here. I want to sort of catch up, and I don't really have something terribly fancy to pitch or say. I just want to show you some tools that are going to really help you. And I'm going to show you the project here, because I think that's also helpful to see. So the last piece that I have here is designing our solutions. And I'm going to show you a very, very, very rough architecture for this little tool that I've created with a couple of coworkers. It's called Hasura, which is definitely a ripoff of Amazon. So there's that. But essentially, it's a little e-commerce application. But what we're doing is we have taken a CSV of some dummy data. We've dumped that into our database. We extrapolated out a couple of SQL statements, find the tables, put that inside of Hasura. And as soon as you do that, you have an API. And then utilizing NextJS's server layer. So we have NextJS being able to actually perform the need of our NextJS is actually hosting the website, and then it has that API route. And that API route allows us to go ahead and do fairly unauthenticated behavior inside of this server context, where for the prototype phase, what I just need to do is get paint on the page. So I'm able to, from my front end, reach out to now this hosted function that's part of the NextJS framework, I can reach out to there, I can do my data fetching, and then I push this back down to the actual front end again. And also my API route, I'm reaching out to my data service. So API route NextJS, data service Hasura, and then Hasura is actually pushing this data as a response back down to the client that was making the request. And so you have this ability to create a believable environment with already a execution environment in place, which is a fantastic concept when it comes to the speed of getting things out the door. So I'm going to go ahead and switch to showing code now to show at least a couple of windows here. So let me go ahead and switch over to a presenting mode here. So I'm going to switch to some code mode. So there I am again, back on screen. What we have is, this is the Hasura interface. And the Hasura interface, basically, you've got tables that you can design. So I've got like a product in this case, and I'm viewing the actual data. But I wanted to modify this. I mean, PG Adam and eat your heart out. You can add a column here. You can add any of the supported Postgres data types. You can write your GraphQL types if you wanted to. And then you're able to simply add all the supported data you need. Define your relationships, how you want to connect them to other parts of your application stack. So one-to-one, one-to-many, those kind of things. And then you have the defined GraphQL API already available for you. So you just do things like starting to use a GraphQL environment, say product and name, and then you get the data pushed out to you just like that. And Hasura lets you scale all the way up to user accounts. It lets you scale to protected individual ownership of data. Hasura can handle anything that you want to throw at it in terms of data architecture, but it's also extremely fast to get started with, because it really is about coming into this data layer, adding a new table, just whatever you want to call it. You know, this could be the shopping cart. Let's actually do a valid table name or Postgres table name. We'll go ahead and give this a custom ID, or I'm not even going to do that. I'm just going to say, you know, use one of these pre-built ones. Go ahead and give me a unique one right off the bat. And then I've got, you know, a new table with a random ID, and it works. And I can work this way in a very effective, in a very fast way of prototyping and developing. I can go back and later change fields. Let's have a quick look at the actual application we're in the process of building. So I'm going to get out of the screen here for a second. You can see the mark of the prototypes here. Down here, what we have is a very helpful printing off the filter logic to the page using JSON stringify. I mean, this is a real prototype, right? So this is something we're building to show off some of the features of Hasura. But this is real data coming from Hasura, loading on the page in production grade format or way. I mean, it needs to be tightened up, but this is, you could run with this. You could build a company like this. And this is exactly about the level of realism that you're able to layer in using tools like NextJS and Hasura. So let's have a quick look at NextJS. I'm going to try to wrap this up a little bit quickly because I know that the last one went a little bit long, so I'll try and end a little bit short and everything ends happy. Let's have a quick look at the different parts of an NextJS application here. So what we have here is just a little bit of ETL work for processing those CSV files. We have our entire Hasura project. So again, offline first management, Flipkart data. We have our metadata defined from Hasura as far as, you know, what the relations are, what the permissions are. We have integration statements that are written as standard SQL statements. We have C data, everything else. Again, this allows me to work in an offline format, and I can run migration statements to push this data right up into the cloud. I have a Docker Compose file, which allows me to run a Postgres environment and a Hasura engine environment as well with just a simple command, because again, you want to talk about moving quickly. I have a sketch folder here to simply just the resources from the designer so that I'm able to reference those inside of my project. And then we have inside the WW here, this is just the Next.js project. doesn't have to be in www. I just do that as a convention because I'm old. But this is something that I find really helpful. And Next.js, that index page, if we just drill down onto it, so here Next.js supports TypeScript out of the box, and we can mix Java and TypeScript too. So I'm not a TypeScript person because not a lick of this here is TypeScript, but it still executes just fine, and it will scale to TypeScript if I need to. What I have is base page, and here it's actually fetching this all offers thing. And the all offers thing, you can even see I'm, data fetching hack. Something I even called it for one of the tests that I was doing, prototyping content, just going to my local file here, this API path, loading in the data, iterating over it, standard kind of React things if you're not a React dev. And all I have to do to define that API route is I come into my pages, I have this new folder called API, and then I have this endpoint called offers. And that offers, you can see that I've tested a number of primitives here. Basically, I'm just making a request for some data from Hasura, and then I'm dumping it back to the client inside of the response. And again, so for as hacky as all that is, and I'm messing around and I'm testing things out and I'm trying different things, when it comes to what I'm showing the client, it's believable. Like, this looks real. And so this is the magic of the prototype process, where you're able to say, I'm going to use these simple tools to be able to say, I can work quickly with these tools. I can iterate quickly with these tools. And I'm able to then scale this to a real production grade environment for my customers to be able to work with and be able to see this. And I can push this to different production environment and development environment and everything else. That is, I talk extremely fast. Do find me at Motley Dev. Ask me any questions. Pop any questions you have as well, and I'll answer those in the Q&A a little later. There's a lot to kind of unpack inside of that. But what I want you to take away is that as you're learning the solutions architecture craft, I'll set up with a translation that we have in the German language. I'm in Germany. And basically it says that everybody's cooking with water. And I like that a lot, because basically the idea here is that every single major application you see has these pieces behind it. It's all the same. And so, yes, there's different levels of fidelity, there's different levels of scale, different levels of, how many people get fired, something wrong at the end of the day. But when you're talking about being a solutions architect, there's nothing stopping you from being able to pitch the most wild ideas to a customer and be able to embrace a couple of simple tools. The power of Next.js, the power of Hasura, which is, mind-blowing. I'm just new there. My brain keeps exploding about what it can do. Using tools like those allow you to go from nothing to quite believable to full production in very few steps. So embrace the path of the prototyper, embrace your tooling, learn tooling deeply. I would highly encourage you to learn JavaScript and GraphQL, because those will be the painting and data primitives that I foresee coming down for the future for a long time, and will get you very far as a solutions architect. But learn your tools, learn them deeply, and don't have too many, and you'll do just fine. So that's my career track pitch. I am done, a little bit over, but that's that. So thanks for watching and following me on Twitter.
Thank you, Jesse, for this amazing talk. We'll see you in a while on our Q&A session. So please, dear attendees, don't forget to leave your questions in the comments, and Jesse I'm sure he will be glad to answer all of them on our Q&A. Thank you, Jesse, and see you soon.
Bye.
Okay. I'm sure you enjoyed this talk, and now we are ready to present you the next talk in this blog, which will be by Jan Tsui. He will present at his talk how I built a social network in 4 weeks with Serverless and GraphQL. Jan is an experienced engineer who has run production workload at scale in AWS for over 10 years. He has been an architect and principal engineer with a variety of industries, ranging from banking, e-commerce, sports, streaming to mobile gaming. He has worked extensively with AWS Lambda in production the last 4 years. Nowadays, he splits his time between advancing the state of serverless observability as a developer advocate at Lumigo.io and helping companies around the world adopt serverless as an independent consultant. So, Yansu was not able to join us for the live, so we're going to show his recording of his speech, but don't forget to leave your questions in the comment as he will join us for the Q&A session right after this talk. So we will present his talk just in a
All right, everyone. Thank you for joining us on this talk, where I'm going to talk about how I built a new social network in under 4 weeks using serverless and the GraphQL. So this is related to a project that I recently worked on for a client where I built a backend for a new social network that lets you, mostly university students, register your sporting interests and find other people to do sports with. You can arrange your activities like basketball match and have a group chat, or you can just message each other and to arrange doing some sports together, like jogging in the park. So the client is a bootstrapped, privately funded startup. So there's a lot of constraints on money and therefore development time. And they also need to have something in place before the new semester starts, which didn't leave us with a lot of time to get everything ready in place. So from the get-go, I had some pretty clear goals to work with in order to help me drive technology decisions and what approaches I should take. We want to maximize the speed of development because the client just need to get something done quickly and they can't afford a long development cycle. At the same time, they need something that can scale to millions of users if it takes off. They already have agreements with local universities in Belgium to roll it out to tens of thousands of students right away. And this is especially important because the first version of the app they built with PHP and running on two servers was a complete disaster, and it crashed on launch day. So we can't repeat that mistake. The system also needs to have a minimum upkeep. Again, the client just can't afford to hire a full-time development team to look after this. So it's the system pretty much have to run itself and not fall under. And it also needs to be cost efficient as well as we scale to hundreds of thousands or maybe even millions of users. So the project was put together with a very small team of just 3 engineers, including myself, where I was working part-time, maybe doing 2 to 3 days a week for a good about 4 or 5 weeks, maybe in total. So we didn't just build a mobile app as well. We also built a CMS for the app as well, which will be used by the founders to onboard new universities and to manage the list of predefined sports you can select in the app. And the CMS will also going to be used by the university staffs to manage their profile and to publicize their sports programs. So I'm not going to show you the full architecture, but here are a few of the key components. We have CloudFront and S3 for image assets and videos and such. And for authentication, we use Cognito. There's one Cognito user pool for the mobile app, and then another one for the CMS. And the backend is all done in GraphQL using AppSync. Again, one for the mobile app and the one for the CMS. And they each have resolvers that point to DynamoDB for simple get and put and query operations. For anything that's more complicated than that, I tend to have a Lambda resolver, and that Lambda function might also do something more complex against the DynamoDB tables or other resources. And you can also use a pipeline resolver instead of Lambda for a lot of these things, really. But I just find it's a bit easier for me to do it with Lambda, and it would be easier for me to hand it off to somebody else later as well. And we also use Algolia for search, and Algolia is arguably the closest thing you have to a serverless Elasticsearch service right now. And to get the data we have into Algolia indices, I use the DynamoDB streams to trigger Lambda functions so that whenever data changes in the raw DynamoDB tables, they are synchronized to Algolia. For example, whenever a user creates or updates their profile, or when they start a new sports activity in the app. And also capture business intelligence events from the different Lambda functions and use a Firehose delivery stream to buffer and batch them into S3. And so we can then run BI analytics against them using Athena. Again, this is not the actual architecture diagram, but just a summary of the different services I used and how they kind of fit together from a high level. I'm not going to sort of bore you with all the architecture diagrams. It's just going to be a lot of lines between AppSync and DynamoDB or Lambda. Moving a little, bit high up the, I guess the abstractions. So we have different, we have multiple AWS accounts, which is a good security practice and helps limit the blast radius of any security breach. And it also gives you consolidated billing and the billing reports across all of your accounts because we use the AWS organization for managing these accounts. And we have 4 independent organization units for dev, for staging, for production, as well as an org unit for accounts that manage the shared resources. For example, there's a shared users account for single sign-on, and there's a shared account for collecting all the information from different accounts using CloudTrail. And at the root of the organization, we have a couple of service control policies or SCPs, for example, to deny access to all services outside of US 1, because I know that's the only region that we are going to use right now. And also it disables any actions to any attempts to disable CloudTrail or to delete any data that's been collected in the centralized S3 bucket for audit. Again, remember, all of this was done by one person working part-time for a couple of weeks, and it's only possible because I could stand on the shoulders of giants, and really all the hard work was done by AWS and the different service teams, and I can rely on good tools like the Serverless framework to help me manage and deploy my application. So my name's Yantrey. I have been using AWS for over 10 years now. Nowadays, I'm an independent consultant, and I'm also one of the AWS Serverless heroes as well. For the last couple of years, I've been focusing primarily on serverless technologies, including, funny enough, migrating another social network to serverless a couple of years ago. And that was one of my first, forays into the serverless space. You can read all about that with the link at the bottom of this screen. So nowadays, I spend half of my time working with Lumigo as a developer advocate. And the Lumigo, for those of you who haven't heard about them, is a troubleshooting platform for serverless applications, which really makes it easy for you to monitor and troubleshoot any problems that you find in production with all your Lambda functions and AppSync APIs and so on. And the other half of my time, I work as an independent consultant where I advise and help companies adopt the serverless technologies through trainings, through advice, and sometimes working with clients like this one to help them deliver a MVP very quickly. So outside of my, professional work, I also written a couple of books with Manning, published a video course with Manning as well. And recently, I also published a new video course on AppSync, which is open for access now on the appsyncmasterclass.com. And I also run a weekly podcast called Real World Serverless, where I talk with other people that also build things in production with serverless technologies. So I'm sure at this point, most of you already heard about GraphQL, and so I'm not going to take too much of your time here. So essentially, GraphQL has got this schema language that lets you define the data types and operations that your API supports, including queries for fetching data and the mutations for, mutating them. And then the client of a GraphQL API will send a query or mutation operation to a GraphQL server that implements this particular schema that you have defined using this GraphQL language. And the Polo is probably the most popular implementation of a GraphQL server. In this case, a GraphQL server with the validated request against the schema, and your pass system, and then in turn, it's going to then fetch the data from different data sources and then stitch them together in the format the client has asked for. So think of it as your backend for front end, except you don't have to write bespoke endpoints every time the client wants another piece of data or he wants them in a slightly different shape. So as for AppSync, it's basically a fully managed GraphQL server, which allows you to map those queries and mutation operations, as well as the data types you have, to different resources in your AWS account. So out of the box, it supports DynamoDB, Lambda, Aurora Serverless, Elasticsearch, as well as any raw HTTP endpoint out of the box, which you can use it to integrate with a number of different AWS services, as well as any internal services that you have that may be still running REST. So as an example, as a logged in user, if I need to call the app, call the backend to fetch my profile, and in this query operation, I'm able to fetch everything I need in one single operation, including my ID, first name, last name, gender, and what sports I like, all of which are mapped to a profile table in a DynamoDB table. And so AppSync would then fetch my profile using the authenticated user ID that Cognito has resolved, and then I, as a client, I'm sending a request to the backend using my JWT token that I have received from Cognito. And then the list of the sports in my profile, it only contains the ID for the sports, because we want to be able to change the display name or image URL for those sports. So we don't want to be baking them into every single user's profile. So we're going to need to expand those IDs into a full sport object and fetch the image URL and the display name for each of the sports that a particular user is interested in. So within GraphQL, that's called a nested resolver. And in this case, AppSync can then fetch those information from the sport table in DynamoDB. So we're also good there. There's no need for the client to send two separate requests, saving us some additional round trip and hence saving the problem of the so-called N+1 request problem. And as for my activities, since I can have many activities, so when I fetch my profile, I really just need the first page of the activities I have for the next list of next set of activities that I'm going to do in the future, which is likely all I'm ever going to be interested in when I'm looking at my profile. So AppSync runs a query against the activities table where the data is stored with my user ID as a hash key. And then the timestamp of the activity is the range key here. And so we can easily get a page of activities in descending order. And since other people may also ask to join my, say, basketball match next week, I also want to be able to fetch any requests people has made to join my activities as well. So again, we only store the user ID in those requests. And to display the request in the UI, we're going to have to expand those IDs into those users' public profile. So we can get their names and profile images and so on. Again, from the using a nested resolver, that's also going to get the data from the profile table. So as you can see, this is very flexible. The client can basically just ask for anything they want. But you probably also sense that there's some danger here as well, that the client can end up asking for a lot of information, and you can have a very deeply nested queries that can start to impact performance and cost, because you're going to be making so many different requests to DynamoDB. So luckily, you can mitigate some of this by enabling caching in AppSync, which lets you sort of control caching on specific resolvers, and you can adjust the cache TTL on those specific resolvers as well. And also to help me prevent further nesting and to prevent leaking any personal information like date of birth and things like that, we have different data types to represent the profile that you will fetch for yourself versus a profile for other people that you want to see. So when you see other people's profile in the app, you only see the public portion of that of that profile. And also that the public profile type is much flatter so that it doesn't allow for a lot more nesting from that point onwards. So that one query returns all the information I need from the front end to sort of render my profile page and to show the different sports I'm interested in and how good or bad I am at those sports and so on. And when you see other people's profile, you're looking at the data that's only available through their public profile, not information that they don't want, that we shouldn't be sharing publicly, things like date of birth and address and things like that. So AppSync itself is very scalable. The GraphQL subscription implementation, for example, can support millions of connected clients, and the AppSync API is deployed to multiple AZ or availability zones out of the box, which gives you a great baseline for resilience, and you only pay for what you use at about $4 per million operations. And as I mentioned earlier, it's got built-in support for caching, which charges you extra. Essentially, you're going to be paying for uptime for a memcached node. And it also has a built-in monitoring support with CloudWatch and the CloudWatch logs as well, where you get the high-level metrics like the number of API requests, error count, and latency, which is great. But unfortunately, these are all aggregated, so it's difficult to tell which resolver is causing a problem with, say, higher latency or maybe a high number of 4SX or 5SX errors. Since a single resolver, so a single GraphQL request can involve many resolvers. So luckily, you can also enable logging, and once you set the field level attribute of the resolver log level to all, then you can get a lot of information about what's going on. You can see the state of what's going on inside AppSync, as well as the transform the template request and response templates. So you can really quickly narrow down to specific requests that took a long time, and then see, or maybe there's some business logic problems in your template, and you can really quickly find out what the problem is. So for performance issues like this, you can also enable X-ray as well, which really shines a light on what's happening behind the scenes, and shows you a little timeline chart that shows you which operation is done when, and I guess proportionally how much time is spent of the whole request on, say, a particular DB call or a particular Lambda function invocation. And the X-ray also shows you a service map as well, and so you can get a high-level view of which services your AppSync API is talking to, and the overall health as well as performance. So it gives me all of this out of the box, and I don't have to manage any servers, which is pretty amazing, considering that I'm one guy trying to manage the entire thing. You might also notice that I've got quite a few DynamoDB tables. It's I guess right now it's about 15 tables and more. And if you've been following what's happening in the DynamoDB space, you may have heard about single table designs and wondering why I didn't condense some of this or all of this into a single table. So I do use the modeling techniques that people advocate for with a single table design, and I do put some entities into the same table. Things that tend to be, queried together. But other than that, I don't see why I should force myself to arbitrarily put everything into a single table. In most cases, it's just not practical. And I'm also quite careful with using global secondary indexes, because there's some serious impediments if you have too many of them. For starters, CloudFormation can only update the one global secondary index at a time. So if you ever need to add the two global secondary indexes in one update, then you're kind of stuck. If you ever need to rename a global secondary index, you're also kind of stuck, because that's two operations. And you have to carefully manage your commits and what you push through your CI pipeline, so that you don't ever update more than one global secondary index at a time, which is just so easy to mess up. And also, when you're building something new, you haven't figured out all of your access patterns yet. And whenever you change your mind, those changes are going to be difficult, especially since you can't deploy two global secondary indexes changes in one go. So do you really want to deal with that? I know I don't. And often when I need to read a couple of related items from different tables in one single request, which is oftentimes one of the reasons why you might want to consider using a single table. Well, AppSync kind of just takes care of all that complexity for me anyway, and it stitched them together for me nicely after it's make multiple requests to different tables. So some of the sort of advantages that you get with a single table just doesn't quite translate, or this is not as valuable when it comes to working with AppSync. And if I was to use a single table design with AppSync, then I also end up just having to write a lot more custom VTL code than I would like to, or I have to otherwise. And I don't know about you, but I don't know many people, I don't know anyone who really likes VTL. It's not exactly the nicest thing to work with. But what about the potential cost savings? One of the arguments for single table design is that you can use one query to fetch multiple items, and the way that the read units are calculated based on item size means that you can potentially save a lot of read units with queries. So you have one query to read the 4 items, that might count as one read unit, whereas if you have multiple tables, then that could be 4 separate get item requests, which will count as 4 read units. Well, you know what? A sensible caching strategy is going to save you a lot more than single table design ever going to save you, because you're going to cut out most of that request to DynamoDB before they even happen. And also, unless you're operating at a high enough scale, those micro savings just doesn't mean anything meaningful when it comes to your DynamoDB cost. And for this application, I got a 99% cache hit rate on average throughout the whole day, which means 99% of requests doesn't even hit DynamoDB. So we've been live for way more than over a month now, and in that first month, we ended up with about 250,000 API requests a day, and for that whole month, we had a lot of requests to DynamoDB because some of these operations are really quite intensive. But at the end of the month, our DynamoDB bill was like $4 at sure, at super high scale. And if you're talking about Amazon.com, then those small cost savings from single table design can be really significant. But for a lot of applications that you and I are building, we are just never going to really hit those numbers. And even in the cases where we have a lot of throughput, again, a sensible caching strategy can be far more effective at the cost saving compared to making your application more complex using single table designs. For this app, I really don't need to optimize for the best performance or scalability. And having multiple tables is more than sufficient, at least for the foreseeable future for this app. And the thing with a single table design is that it's just more complex. It requires a really thorough understanding of how DynamoDB works, especially in terms of a global secondary index. Now, I don't remember who said this, but I do prefer to design my system as if it's going to be run by idiots, because one day it will be. And in most of cases, that idiot is myself in 3 months' time when I look back and I can't remember why I did certain things. So as much as I enjoy, the single table designs techniques, and I do use them sparingly, I just don't think it makes any practical sense for me to arbitrarily restrict myself to using one table for everything. And in terms of authentication, as I mentioned earlier, we use a Cognito user pool, and I set up an identity federation so that users can sign in using Facebook and Apple as well. And on the client side, we use the Amplify.js library to integrate with Cognito, which really makes things quite simple as far as authentication is concerned. I didn't use the Amplify CLI to create and configure the Cognito user pool. I configured it with CloudFormation in the serverless framework because, well, I already know how to do it. And if anything, I need to know what's been configured. And I also think that while the Amplify CLI is great for quickly bootstrapping a new app, especially for a team that doesn't really have a lot of experience with AWS and Cognito, it helps you get something going quickly and gives you some good defaults. But I've also heard that it doesn't do so well with some changes, and a few people have told me that they've had to delete the entire stack when it got stuck and they can't deploy certain changes. Again, that's just not something I'm willing to deal with for a client project that I need to maintain in production. And the Amplify can also provision and configure the DynamoDB tables with AppSync API for you as well. But I don't agree with a lot of the decisions that it makes. For example, how it defaults to using DynamoDB scan for list operations. And in this particular case, the DynamoDB schema and access patterns are really important, and with potentially huge scalability and cost implications. So I want to have a tighter control around that. I need to really understand my access patterns intimately. And ultimately, I think it's just hides a bit too much details from you, and not being able to easily drop down to CloudFormation and then change some of the resources or how they're provisioned. It's going to really restrict me when I need to make changes and evolve the app going forward. So moving closer to the code, I use the server framework instead to help me package and deploy my application, because it's, well, very mature, it's got a great community around it, it's very extensible through a whole range of different plugins from the community, and we're going to see two of these in a minute. And I was already very familiar with it. It's been my go-to solution for a number of years, so I'm very proficient with the serverless framework. And in this case, I've got one repo for the whole backend, and everything is configured in one serverless YAML and is deployed as one CloudFormation stack. So resource reference and all that was very straightforward. Even as the project continued to grow and to deploy, I just had one command I need to run: serverless deploy. That's it. And to make it easy for me to configure all these different resolvers I had with AppSync, I use this plugin called the Serverless AppSync plugin, which really made things quite simple. As I mentioned, I had the two AppSync APIs, one for the mobile app and the one for the CMS. So I broke these two out into their own files to keep things a bit tidier and more manageable in my main serverless YAML. And each of these AppSync, files is going to look something like this, whereby I configure them to reference the right cognitive user for authentication. I configure the login setting in production. We don't want to be logging everything because it's going to generate so much logs to CloudWatch that the cost associated with that is going to be a problem. And then I configure my resolvers and data sources in the same file. For many of these resolvers, we are going straight to DynamoDB. So the request and response templates have to be written in the VTO, which is the same templating language that the API gateway uses as well. So I'm kind of familiar with it already. And honestly, I think the feature documentation does a decent job, and it gives you a bunch of examples that you can just follow. And most of them look quite simple anyway. But if you start to write more custom code for business logic in VTL, then at that point, maybe you want to think about moving those logic into a Lambda function instead. So as the project grew, I pretty quickly hit the 200 resources limit in the CloudFormation, which luckily AWS has since then increased that limit to 500 resources. But at the time, it was still 200. And we hit that 200 limit pretty quickly. So luckily for us, there's also the split stacks plugin, which can split your one stack into multiple CloudFormation stacks by splitting some resources into nested stacks. And after some trial and error, I found an approach that can help me just let it continue to scale the application. It doesn't matter how many resources I have, I guess within reasons. So in this case, we have two AppSync APIs with over 200 resolvers and the total of more than 600 CloudFormation resources, and they split across multiple nested stacks. But in a way so that we can continue to grow the application and add in more and more features, and it's not going to hamper, and that CloudFormation limit is not going to hamper us. Which kind of brings me to CI/CD. Since the whole code base was already in GitLab, I decided to just use GitLab CI/CD. And the one technique I've used in most of my projects is to install the server framework as a dev dependency, which means I don't have to manage any extra dependencies on the CI server, and I can just have a very simple helper script in my package.json. So basically, just the npm CI to restore dependencies to the exact version I had in the project as they are configured in the package.json file, and then run the npm run serverless deploy to trigger deployment using the version of the server framework that's been installed in the project as a dev dependency. And that's it. That's basically my CI. So it couldn't be simpler. And when it comes to testing, one of the challenges with using something like AppSync is that it's a managed service. It's a black box. So how do you test it locally? I mean, there are tools that can simulate appsing locally. I don't tend to bother with them, as they don't cover everything, including IAM policies. And honestly, I think those VTL templates are so simple that most of the time they just work. Where it tend to where it tend to go wrong is in my Lambda functions, where I tend to do more complex things. So with VTL templates, you can also, and I do sometimes, write unit tests for the templates themselves. But most of the time, I tend to focus on my testing on the Lambda functions, because that's where I do more integration with other services like Algolia, or do more complex things with DynamoDB. So what I can do in that case is to execute a function locally and have the function talk to the real DynamoDB tables or Algolia as part of my integration testing. I don't tend to use mocks or stubs or simulate those services locally with things like local stack. I just find things like local stack takes too long for them to to configure them, to get them working properly, and they're quite brittle as well. And it's just much easier to provision those resources and then use them in my integration tests by executing the Lambda function locally. And then once I've got some confidence that the function is doing what it's supposed to in terms of how it integrates with other services, I will deploy the function to some environment, and then I can have end-to-end tests that run user stories like user logs in, creates a profile, then does a search, and then joins another user's activity, and so on. And I can run those tests against the deployed GraphQL endpoint or AppSync endpoint. So this will always be run after a deployment. And if you have any failed end-to-end tests, then great. Use this as a rehearsal for how do you debug real problems in production. And if this process is difficult, then guess what's going to happen when you do have a problem once the system is live. Use that as a signal that you need to improve how you're logging, how you're monitoring the system, and enable X-ray tracing if you need to. And if you're struggling to debug failures or problems in a controlled environment like your end-to-end test, then you're going to have a much bigger problem when this thing is running in the wild. So don't optimize for your comfort, and with these local simulators, is a false sense of security. And finally, let's talk about the AWS organization setup. So I mentioned I had the several org units and AWS accounts, and I don't want to manage all of this by hand. So I want infrastructure for as code for this as well. Luckily, there's this tool called Org Formation, which gives me exactly that and lets me provision and manage my entire AWS organization with infrastructure as code using a YAML syntax that's very, very similar to CloudFormation. And I can also use it. It also makes it easy for me to template my landing zones, which is basically what are the basic infrastructures that should be provisioned on a new account, things like KMS encryption keys, VPCs, and so on. So in this case, I was able to declare a master AWS account and as the root for my organization. Again, it all done in code using a syntax that's very similar to CloudFormation. And I'm able to provision a new account and then set up budget alarms with just a few lines of code. And I can attach these accounts to my org units, which I also created in code. And I can also configure service control policies. For example, here, I know the only region we're going to be using is the EU West 1. So I can set up a service control policy that denies all actions against regions other than EU West 1 and apply this policy to the root of the organization. So it gets applied to all my AWS accounts. I can also configure my password policy for AWS users and use this password policy in all of my accounts as well. And whenever I make any changes, I just need to run this one command to update my entire AWS organization, as well as update all of my landing zones. And to configure my landing zones, I can configure what is called a task, where I specify basically a CloudFormation template and provide the bindings to my organization, which basically says which resources from the template should be created in which AWS accounts by binding its resource to org units or to specific AWS accounts. Okay, and here's an example of one of these templates where I basically have just a normal CloudFormation resource for an IAM user, but I can bind this resource to a subset of accounts in the organization using this concept of organization binding, which is a way for you to filter accounts by org units and so on, so on, and so on. It looks a bit funky, but basically here I can iterate through the AWS accounts that are provided by a binding. I mean, don't worry if the mechanics of how this actually works looks a bit alien to you. Once you spend a bit of time with org formation, it will start to make a lot more sense, and you'll find things like this to be very, very powerful, and things that are really difficult to do otherwise. And to update my landing zone, I just have to run another command, and that's it. Again, everything's hooked up to CI. It's just really easy. It's a really powerful tool, and I do recommend that you check it out. It's available from GitHub, and it's maintained by someone from who used to work at the Money, which is a bank here in the Netherlands. So that's the kind of the three main tools I've used in this project: the serverless framework for deployment automation, AppSync for the managed GraphQL server, and the org formation for automating or any automation around the AWS organization itself. And if you go back to the goals that I started with, in terms of speed, getting everything done within 4 weeks is pretty good, considering the amount of stuff that's involved. And I was only working part-time on this project as well. So speed of development, check. AppSync can scale to support millions of users. Absolutely no problem. Check there as well. And I have 0 EC2 instances and no servers to manage. So, and no networking, VPC, and all of that. So in terms of upkeep, yep, definitely minimum upkeep, check. So as for cost efficiency, so we've been live for a little while now since I guess Belgium went into lockdown again. The traffic has definitely dipped significantly, but right after we launched, we had over 15,000 organic installs, and we were averaging around 250,000 API requests per day. And our AWS bill for that the first month and two was around $60 per month. And most of that was just the API to AppSync caching. And considering that we were using about 5% of the cache capacity, so that $31.68 is going to be pretty flat even as we continue to grow our traffic by 10x once I guess the pandemic has finished and people are back to doing sports and back to going to universities and the sports centers to do yoga classes and things like that. But yeah, this is, and the AppSync caching is going to save us tons of money on the Lambda and DB costs. And besides what you see here on this sheet, there's also another like $15 or so on the CloudWatch logs and X-ray and so on. So all in all, pretty reasonable price to pay for something like this for the whole backend. Oh, and in terms of the latency, in general, it's also really good as well. P99 is stable around the 500 milliseconds during the day when people were using it. But when it's in the middle of the night in the Belgium, where the app is actually mostly being used, you can see those P99 start to go up because there are more Lambda cold starts, fewer people using it, and other things like that. But overall, we are really still quite happy with what we're seeing in terms of the performance and scalability as well. And that brings me to the end of this talk. Again, I want to thank you guys very much for being with us at this conference. As I mentioned earlier, I spend most of my time as an independent consultant. So if you want to see how Serverless can help you go faster or just need some help upskilling your team, then let me know. Go to theburningmonk.com to see how we can work together. And as I also mentioned before, I've got a new video course on AppSync. So go check it out at appsyncmasterclass.com to see how you can build a Twitter clone using things like AppSync, Lambda, DynamDB, Cognito, Vue.js, and Tailwind CSS. And with that, thank you and stay safe.
Thank you, Jan. I'm sure everyone enjoyed this session. It was really interesting and valuable information. And I see that all of our speakers are already ready to join us for our Q&A session. But before that, I would like to announce that we have a new format. Geekle is moving to a new format, and starting from today, everyone can join Geekle educational platform to get access to the recording of all of our amazing events, both past and upcoming. Also, we are starting new series of weekly episodes focused on different aspects of developers' growth. Here are some details on what benefits you will get by joining our community. weekly online meetups with unique content from top speakers, videos from past and upcoming summits by Geekle, worldwide networking with a community of more than 60,000 of developers. Don't miss out an opportunity to receive your free trial today, as all attendees of the Worldwide Software Architecture Summit will receive 21 days of free access to the platform. You can join Geekle Educational Platform using the link that I will share in the comments. And now we are ready to meet all of our speakers for Q&A. Hello, hi all.
Hello.
Okay,
Hello.
yes, I think let me
Hi.
know if you can see and hear me well. Yeah, I think everything is great. So, I'm sure you all are in a great mood and ready for some questions. And dear attendees, you can now start asking your questions, and all of our amazing speakers will be happy to answer them. So let's start. We have first question is to Runcy. So, what are the security considerations we should keep in mind when going serverless?
Hey, hi. Thanks for having me here. So that's a really great question because security is sort of like the very you see there is security that's going to start at all the 7 layers, right? And the serverless is mostly sort of like the layer that's mostly on the application layer or the one on top, right? So you have to think on various aspects of when you design your services for the serverless. So the things that I mentioned was basically about the static website hosting, and that included the various components that use from S3 to API gateway to lambdas and all the other things. But serverless is not just about the fast or the lambda. It's also about all the other things. So if you use the S3 bucket, you have to make sure that your buckets are having the right permissions. If you use API gateway, make sure you have the proper keys that's been associated. It's not just an open API gateway. So serverless is it's sort of like a very broad concept, right? I mean, we cannot just say security for this particular aspect. I mean, S3 is serverless, not just Lambda, right? I mean, if you use Google Cloud, the BigQuery is serverless. So serverless, you should not say that just the Lambda functions are serverless. So depending on what services you use, you have to secure your services accordingly. So there is no just one silver bullet for security for serverless. Yeah.
Okay, thank you. And our next question. So, what do you see as advantages in the serverless approach? What is the best way to convince my management to pursue this approach in layman terms? Okay, I think this question can be asked to all of you, I guess. So maybe someone would like to start with answering, like Jesse?
Yeah, sure. I can probably take a crack at this. So when I've been doing a lot of stuff with serverless, and I've been interviewing a lot of people for my podcast as well, and to understand why they decided to go with serverless. And the one thing that it comes back a lot is just speed. And if you look at some of the reports that Amazon has published last year, I think they were looking at some of the big enterprises and they look at the cost savings of Lambda and using serverless technology, not just Lambda. And you look at the sort of saving, most of that is in staffing. If you needed, say, a whole team of people to look after your infrastructure before, now most of that is being looked after by AWS and probably doing a better job than you can. And so in turn, the engineers you have, you need fewer of them and they can do more, they can deliver more for less. And you see that with a lot of companies who's gone serverless that in terms of the speed of delivery is just amazing. And in my talk, I was able to do all of that stuff for a new startup in just a couple of weeks by myself, working part-time. This is the sort of thing that would have taken maybe the whole team of people to deliver and take longer to deliver as well. So I think the biggest advantage I've seen a lot of people talk about when they've been doing stuff with serverless for a while in production is just the fact that you can get more done, you can be more agile, and you can also experiment with things quickly and without having to worry about all this upfront cost for development and the infrastructure.
Okay, great answers. Thank you, Jesse. Maybe you or Rancy, maybe you have something to add to this?
I can add a layer onto it. So it's going to depend a little bit also on what kind of a business you're in. But one big piece of it is going to be that anytime you have modularized components to anything, you have better efficiency. And so essentially, if you are saying we want to swap out our auth layer for something that supports who knows what, the Fitbit now is a way to log in to work or something. Who knows what the next service may be. If you have a modularized approach, which is something that is a part of the serverless tenants, then you can swap out these pieces later on without having to uproot your whole architecture. And so you're able to upgrade individual pieces to what you're trying to build without having to write from scratch the entire stack again. And that allows for being current going forward.
Yeah. Okay, thank you. Yeah, I think the part of is convincing the management. It's always like interesting to discuss, but depends on the management, of course. So,
Yeah, I think,
Runcy.
like Jesse was saying, that it also really depends on your organization. What's the most challenging thing for your company? Most people I know they will say, we're not getting things done fast enough, so speed is really important. But I think some enterprises might also say security, maybe cost, scalability, and things like that. And you got a really good mix of I think Runcy were talking about security. There's still a lot of things you got to worry about when you're using serverless, but you don't have to worry about the security of the OS, the containers, images, and so there's a whole layer of attack vectors they can just eliminate because it's been managed by somebody else.
Sure. Okay, Runcy, maybe you have also some tips for our attendees in this.
Yeah, I just want to piggyback on Jan's point, and it's from the management perspective, it's just about go fast and break things. That's the whole point of serverless, right? I mean, you can basically get your stuff done very fast, because if you are doing some sort of like a POC concept or get your MVP done in a very short amount of time, then that's the serverless way of doing it. And then comes the actual factoring and scaling and how you actually want to improve your stuff. So from a management perspective, that culture should be there, that there should be a freedom to fail. If that culture exists within that organization, then you can definitely go and build stuff in serverless and break it. And if it's not working, move on to the other thing. So that should definitely help.
Yes, nice. Thank you. Okay, we have next question. What can you say about serverless with microservices?
They are tangent to each other. When I'm building serverless applications, I'm really building applications with the microservice architecture using serverless technologies. I think a lot of people confuse the microservices with containers, but it's just what your code runs on. Microservice is a style, it's how you architect your application around the bounded context and all of that. It's not about specific technology choices you make that you use to run your application.
Thank you, Rancy. Jesse, maybe you have something to add? What do you think about this?
Nothing to add. that is the way. I would say that if you're trying to get your boss to approve the architecture, going back to the previous question, you can figure out what the appetite is for which vocabulary. And so if they are more friendly towards the idea of microservices versus throwing around ideas like lambdas or throwing around whatever else, you can pick the vocab you want to use to win.
Yep, we're building microservices. We just so happen to be running on Lambda.
Okay, Rancy, do you have something to add here?
No, I think they've covered it pretty well. Yeah.
Okay, great. And here comes the next question. So, what alternatives to GraphQL? I'm looking for business level security for my APIs. What can be the alternatives for GraphQL, as far as I understood from this question?
I don't really understand the question. You guys?
I'll take a stab at it. So I think it's a bit of a misnomer that the GraphQL is an insecure API spec. A lot of times because there's some, people don't close down the introspection queries, and so they're exposing potentially some data existence that maybe would otherwise be opaque to an end user. So alternatives to GraphQL. I mean, I think SAP has one. OData is like a similar kind of concept to, and then I think dgraph is another company that has another concept similar to GraphQL, where you're sending a query to an endpoint and then that's getting processed. But GraphQL can be as secure as anything else you want it to be. It's all about access patterns, like the other speakers kind of touched on, and as long as you are protecting the end resources, then there's no issues. I know Hasura even has an example of having API access lists, so you can say only these queries are even allowed to leave the building. And so there's a number of ways to lock down the actual GraphQL pieces, but it's got a bit of a reputation as being insecure because it was adopted heavily by a lot of front enders who were really excited about it, and they weren't maybe aware of access pattern best practices. And so now that GraphQL is getting more adoption, security is a critical piece. But whether you're using AppSync or you're using Hasura or something else to build your stack, it's as secure as anything else.
Yeah, I totally agree. I can't think of any reason why GraphQL is inherently less secure than anything else, just because you have a introspection query that you can find out what the schema is. I mean, everyone knows the API schema for DynamoDB, S3, Lambda. It doesn't make them any less secure. It's what you do with those endpoints, right? It's using the right authentication methods and making sure that people can't do any action against any other user's data, and all of that stuff is just how you build your GraphQL APIs. And the fact that the schema is queryable, it doesn't make it inherently less secure because of that.
Yeah.
Okay, thank you. And next question is again about GraphQL. How to upload file in GraphQL?
I guess the short answer is you don't. The way I often do this is just you've got a query that you ask to give me an upload URL to S3. So in the GraphQL resolver, you just have a Lambda function or something, generate a signed S3 post URL or just a pre-signed URL or a signed post URL, depending on whether or not you want to control the size of the file someone can upload. And some metadata that need to be attached and so on. So you do that, you return URL, someone that can just upload from the client to S3 directly without having to upload it to your GraphQL endpoint first and then upload to S3. Just easier.
Okay,
Actually,
thank you.
do you guys do anything special for that in the Hasura?
I mean, you can, send like a buffer object, and then in your resolver at the endpoint, you could kind of write that to persist that. But that would be not the best way to handle it, because any meaningful file you're wanting to send up would be so massive that you would probably overflow your handler. So best approach would be to use like a mutation statement to either point a local resource to an S3 bucket, or fetching your actual destinations to upload to.
Right.
Okay, thank you.
Streaming, you can maybe stream a file. You can probably start getting to there, but that would be.
Yeah, I don't know. I don't see any reason why you should just replicate what S3 does, especially when the S3 already has the signed URL and all of that. You can put expiry and everything, so you can keep those links relatively well protected. And you can use the signed post URL as well to limit the file size and all that JS as well. So I don't know. Never found the need to actually try to implement upload file on my GraphQL endpoint itself.
Great, thank you. And we are ready for the next question. What is it going to be in the future for microservices with serverless? Okay, who can start? Runcy? What do you think?
I mean, this is sort of like a misnomer in the question. I mean, microservices with serverless, it's basically the same thing as what Yan was saying. So I don't know what's going to be the future. Hey, when I started this industry like about 15 years back or something, I didn't know what cloud was, right? So I mean, and then there was the physical servers that existed, and then came like the VMs with the advent of VMware, and then all of a sudden Solomon Heights announced Docker, and then the Docker was the next thing, And then in 2014, Lambda got announced with, and now everyone is talking about serverless. And we don't know. It's like definitely the future is going to be in hybrid cloud. That is what is going to be there, because there's going to be a heavy emphasis on security, where you want your critical stuff to remain in-house, but at the same time, you want to scale it out in the public cloud. So there's definitely that emphasis, and there's also a lot of shift in the cloud native aspect. And when I say cloud native, that is the emphasis on the CNCF landscape. So there's going to be emphasis for that. So that's how I see the future. As I'll let others give a stab at it too.
Nice. Jesse, Jan, maybe you have something to add? What do you think? What is your point?
Well, I hope the future is not CNCF. I really got a problem with CNCF. It's a marketing organization, and also the whole notion of cloud native they're pushing is about portability, and that's just not what native means in English. When something is native to the cloud, the main thing, it shouldn't be about portable that you can run in your own data center. How's that native to the cloud? But that's, I guess, that's a whole separate argument to be had there. I think Tim Wagner, the guy that used to run the Lambda team a few years back, made a prediction that in the future we're going to see more and more sort of serverless or Lambda-like features on containers, and vice versa. We're going to see more and more container-like features on Lambda, and we're seeing that already. I think in the last reInvent, Lambda has added support for container images, not for running container services, but supporting the packaging format using a container image. And we are seeing things like Google Cloud Run, which has got event triggers, which I hope to see in the things like Fargate in the future. And Fargate is kind of like, I don't want to call it serverless containers, but it certainly makes running containers a lot easier compared to before, when you have to manage clusters and stuff like that. And certainly, I hope that there's more of that features going into Fargate in terms of having easy way to trigger a task using events like you do with Lambda for things that maybe just be awkward to run in Lambda, and maybe because of the performance requirement, but because of the long-running service or requirements you have, things like that. But I think this, the future is going to be, I guess, more of a or coming together of the feature set of containers and the Lambda function and I guess the functions of service. I think that's where we are going, at least on AWS.
Thank you. Jesse, maybe you have something to add in this?
Yeah, I'll speak more towards like where you should sharpen your tooling as far as a solutions architect goes, and definitely learn like CloudFormation languages, something like CDK or something else, because that's going to really be microservices here. It's not going to go anywhere. It's being built into fundamental frameworks like NextJS, which I talked about, and other things. But there's going to be a fundamental piece where if you want to have portability between different cloud providers and you don't want to get vendor lock-in, you'll need to learn some kind of a basically like a spec system that's going to be able to allow you to launch multiple microservices, orchestrate those in a way that you can read, a way that your auditing tools and your CI tools can basically check to see if they're going to actually build or not. Because you don't want to find out that your build's going to break after your 15th service is launched and now you've got a misconfiguration somewhere. You want to be able to basically have code-driven development there. So I would say that learn something like CDK or other CloudFormation languages is probably the next thing for solutions architects to really next level in what they're offering, because one file and you could basically build somebody a startup these days.
Okay, thank you. And I think we have one more question, which is like, again, about the future. Seems like this kind of important question.
Architects, that's what we do.
So, serverless, is it the future?
No, it's the present.
Okay, so what about the future of serverless? Like, will it stay the same? Or some big changes are coming, maybe?
I guess I can probably talk about some of the things I'm seeing on the AWS side of things. Certainly, with Lambda, there's you can see in the last 12 months, a lot of features been added to Lambda to cater for more and more specialized workloads. So if you look at the reInvent announcements, there's been a lot of support for higher memory, which means that you can get more CPU and all of that, container image support so that you can load large static files you need to load to read a runtime. Things like if you got TensorFlow model that you need to load into a Lambda function before you are limited by the 512 mega temporary storage limit you have on Lambda functions. Now you can go up to 10 gig with container images, and we're also seeing ATX instruction set support in the Lambda last reinvent. So that basically means that if you're running any kind of machine learning or HPC kind of workload, then the Lambda becomes more and more of an attractive, I guess, platform to do those workloads. I was talking to someone from the Australia research government research department. They were doing a lot of the work around the COVID-19 to publish information and gene sequencing and things like that. And they're basically using Lambda as a cheap and on-demand supercomputing platform, because you can bring up 3,000 Lambda invocations. So that gives you a lot of CPU cores in one go without having to join the queue for the next slot to run your stuff on the your Blue Gene or whatever supercomputer you've got in the university or government. And so I think some of that workload is going to become more and more feasible to run on Lambda. One thing I guess still missing in that particular space is GPU support. So you can't run Lambda on the GPU machines right now. So with that, maybe that will open up even more doors for different use cases. So I think you're going to see like things like Lambda being used in more and more use cases where before it would have been difficult because of the platform limitations.
Okay, thank you. Runcy, Jesse, what do you think about the future of serverless?
Yeah, I mean, the one answer is serverless is the future. The answer is serverless is the near future. I don't know about the far future, but at least the near future is definitely serverless. Yes.
Sounds great.
I would add the next level that I think this is like really getting futurist. When you start talking about federated services, and in some contexts, there's going to be data and networks and functionalities that, when it comes to data privacy, we want to start talking about where does like blockchain fit into the story, where does the idea of federated resources and access come into. And if you talk about serverless, there's some elements of it that are inherently centralized in terms of where these things are executed. And so the idea of being able to maybe even have one invocation of a function to the next invocation not even being in the same place or even on the same platform, with that kind of ethereal persistence, not having it to be like all owned by Amazon or all owned by Google or whatever else. There's some elements there when it comes to serverless as a way to democratize execution of our code. Like, this is really getting out there on the fringes, but right now we have a problem where a lot of our data is centralized inside of the big three, and we want to talk about ways to potentially protect data autonomy in the future. And so serverless as a path there, but also what would that look like and how will we actually get there is, I think, where a lot of research and discussion is needed.
So on that, Jesse, because you're talking about like invoking Lambda function, that's more about distributing and democratizing compute, not so much data. Because data, for me, I think it's always been difficult to move around or distribute across multiple platforms, because it just
right.
They just
so the ingress and the egress of data through these autonomized functions, like, how is that going to work in a concepts that the federated crowd throw around? How do we potentially leverage the speed we have working with serverless constructs in a federated system? Right now, they're like totally independent from what I understand. And so finding a way to maybe have those paradigms meet is, I think, a good future.
So there are some platforms. I've been talking to a few people, so a few companies who are building new platforms that focuses on kind of like that, whereby one company I spoke with recently, I forgot the name now. They're basically building a platform that allows you to basically pull compute resources from different places, and then they basically build a layer on top that allows you to invoke functions and then execute those functions on different compute platforms depending on what resources available at that moment in time. So you kind of think of it as like a grid computing, but then more like over a bunch of pooled resources from different
computational power or something.
Yeah. So like there's lots of companies around the world that's got lots of spare compute resources that they want, or governments that they're happy to sort of lease out for a small fee for whatever these companies are making from their customers. So there's some stuff that's like that's happening. I'm not sure if that's ever gonna become like a mainstream thing, because there's still a lot of value in using a platform and really getting yourself tightly integrated with a platform like AWS, where you can extract maximum security, performance, and cost efficiency, and all of that.
Totally agree. It's just there's also an element where we want to. There's the checks and balances where there's the element where we can say, I still do a lot of developer education. A lot of the modern developers don't actually know how to write an HTML file from scratch. They only know frameworks or the approaches that, like, the frameworks teach you how to build something, and they don't know like where does the actual base template come from or something. I mean, it's really extreme example, but like if we lose a little bit of our autonomy when it comes to how we even build these tools that have changed our existence, then we're going to run into a problem. But I'm taking this conversation in a totally different direction than I think it intended to go. But yeah, if you want to talk about the future of serverless, finding a way to abstract the benefits we have of serverless as they've been presented and shaped by the big tech into a more democratized format, because ultimately whatever data you process through a function leaves a fingerprint on the service that you're running it in. We trust it that it's not persisted, but at the end of the day.
Okay, thank you. I think we're already running out of time, so thank you so much, all of you, for participating in our event, and of course in this Q&A. It was a pleasure speaking with you. So I hope to see you soon on our next events.
Thank you.
And hope you had a great time.
Thank you. Yeah. Nice meeting Jan, Jesse, and Victoria. Bye-bye.
Likewise, Runcy, Jesse. Take care, guys.
Bye.
Bye-bye.
Okay, thank you to all of our speakers, and thank you, our amazing and quite active audience. So now it's time for us, first of all, to remind about our subscription that Geekle moves to a new platform. I'll share the link with you so you can follow it and stay with Geekle. And also, now what we're gonna do is we're gonna show the first results of the giveaway for the free ticket. And for this, I will welcome, let's say, the queen of this event. The person who was creating this event from the very beginning, Anna. I'm sure everyone already know her. And here we are. Yeah, let us know if you can hear both of us actually. Це будь-які вибори. You can choose any, I think.
Perhaps this one. Please,
Yeah.
Can you tell us if you can hear both?
Yeah, please mention it in the comment. Okay, and now I hope you can hear us. Please let us know.
Please let us know.
Yes.
We cannot hear, Anna. We cannot hear. A moment, please. I will solve this problem shortly. Well, I hope you can hear me now.
Oh, now you can.
You can?
We'll stay closer.
Yeah, let's try to do that together.
So now we are going to share our screen and to do it in front of you.
Yeah, but first let me give many thanks to our speakers. Jan, Jesse, Runcy, you were amazing. Thank you so much for these great talks. And thank you, our moderator, Vika, for being helpful, active, and I really appreciate that. So, yeah, perfect. You can hear me. That is great. That is why I can share our screen. Okay, I hope you can see all these people, the most active ones who asked questions, who were active during the first part of our Worldwide Software Architecture Summit Day 2. And now we would like to choose 5 lucky winners to provide you with the tickets for the upcoming events by Geekle at your choice. So let's imagine, or even let me make some like drum roll. Okay, we got time doing.
And let's see.
Woohoo! Yeah, great. So we can see 5 lucky winners. There are 5 of you who were so active and so lucky that we are happy to congratulate you and provide you with tickets. We're going to copy these names to our chat, I believe. Yeah.
Yes.
Right
you
now.
can see them right here. And please let us know if you are here and if you see your names.
Yeah, so dear friends, if you can see these names and you are one of them, please let us know in comments. And if not, we will definitely contact you all via email, provide you with the details and with your tickets. And we look forward to seeing you all at our future events. Thank you so much. And now, floor is yours. And
yeah, I would like to remind that we are going to change the link right now, so please guys stay with us. I'm gonna share the next link right in the comments below, so I hope you're still ready to hear the even more interesting and valuable information, so please stay with us. I will share the link in the comments and we will be right back.